Awesome. Okay, cool. So today we're going over hashes. And again, just like in today's the 28th, sorry, you guys, I had to push this back, but thank you all for joining me tonight. So yeah, this is basically we are going over a hash map, or what a hash is. It's also known as an associative array. It's also known as a dictionary in Ruby. I'm referencing some material from Robert Horvick, not as much as the arrays. His class is pretty light on hashes and hash maps in the algorithm series, but if you guys want to follow along or review this, this is where some of this information is coming from. It's a Pluralsight class. They might offer, maybe they offer like a free tier, so maybe you can check it out, but it's pretty good. And it's his first series. So tonight we did our icebreaker. We're going to go over hash properties and code. And I'm going to, like I said before, give like a practice leak code. It's a very, very simple one. And if you guys can, I'm going to break you up into breakout rooms. And even if you just want to like discuss how to use or code this in pseudocode, that's totally cool. I'm not going to break you up on, oh, sorry, Yoshi. I'm not going to break you up based off of your languages like they do in Coffee Code Break, because we won't have time for that. But I thought it would be cool to like incorporate a practice and have you guys discuss how to use this data structure amongst yourselves. And then we'll go into questions or Q&A at the end, and maybe share some thoughts after we go over a solution. So our mission, we'll just go over some housekeeping items. Our mission is inspiring women to excel in technology careers. Our vision at Women Who Code is a world where diverse women are better represented as engineers and tech leaders. Our code of conduct. Women Who Code is an inclusive community dedicated to providing an empowering experience for everyone who participates in or supports our community, regardless of gender identity and expression, sexual orientation, ability, physical appearance, body size, race, ethnicity, age, religion, socioeconomic status, caste, creed, political affiliation, or preferred programming languages. Our events are intended to inspire women to excel in technology careers, and anyone who is there for this purpose is welcome. And if you guys want to read more about this, you can go to womenwhocode.com, code of conduct. Please, and again, I'll just keep, keep referencing our Slack channel. Please join our Slack channel. The more the merrier. We love having more women come into that community. All right, so let's get started. Everyone ready? So like we did last time with arrays, this will be primarily in Ruby. That's what I will code in. So let's go over why hash maps. Unlike arrays, which are mere lists, hashes are like dictionaries. You can use them to look up one thing or by another thing, which we will talk about why this is important later. Today, we will not cover collisions, and we will refer to the built-in data type of a hash map. A hash isn't, so here are a few cool things about hashes. A hash is an object that holds a key and a value pair. A hash keys must be unique. We can access individual items within a hash by the key or by the value. And they're also, as I mentioned before, called associative arrays. They are similar to arrays, but where an array uses integers as its index, a hash allows you to use an object type. So in the key, if we want to look up a value that's stored with a specific key, we need to pass in the functions I'll show in a second. We need to pass in the key value or the value to get the key. And it's really helpful for us because the lookup time is very quick and is pretty optimal. So hashes are arguably some of the best ways to store and work with data, especially in Ruby. They're very fast. All right. Are there any questions so far? I did kind of go over that pretty quickly. Okay. Everyone feel pretty good about hashes? All right. So now we'll go over like what I'm going to code a bit. And I have a few things that I made for you guys tonight. So that way you can take the code home with you. And Heidi was a part of another class with me, but I also learned a nifty trick. So you guys can change the code that I have tonight into something else. Like you can translate it into a different language. All right. Cool. All right. So I'm going to go ahead and move on. So I'm trying to get through this by 7:30. So then we can do our leak code challenge. It's a really small question, super small. And thanks to everyone joining our Slack community. We really love it when you join us. All right, so let's go ahead and create, access, and manipulate a hash. Let's review some terms. All right, so a hash is normally created, or an indicator of a hash is by a bracket, right? And inside the bracket, we'll have a key, and it can have a colon, and like you see here, or it's going to have maybe a rocket. In Ruby, we use something called a rocket, so it looks like this. Okay, I'm not sure about in other languages, so I apologize for that. So if you're here and you're a Python or Java or C++, C#, if you want to kind of write in the chat what the indicators of a hash are, that's awesome. So the key is where the data or value is stored. The value is the value stored at a specific key. So types, hashes can use any kind of objects as keys and values. So this is where it gets kind of cool. Awesome. Thank you, Larry. So yeah, you're right. JavaScript. I knew I was forgetting a big language. So yeah, the cool thing about a hash is that it can kind of mix, between objects, which is really nice, right? It can be really nice. Awesome. Thanks, Del. Access to values by a key value, or you can access a key by the value. All right, we're going to go through all this in a minute. Assignment, you can set a key value pair in a hash. Insertion, adding values to a specific key. Deletion, you can delete a key value pair, delete a value at a specific key. And iteration, you can loop through a hash by the keys, key values, or values. All right, we're going to go over asymptotic analysis really quickly as well. So like we learned last week, this is just a quick refresher, okay? So what is this? What is big O? What is asymptotic analysis of an algo? So we want to go and look at how many resources are we using, right? So we're going to look at the operations, the number of times we need to perform some operations, right? The memory, how much memory is consumed by the algorithms. And then there are others like network transfer, compression ratios, and disk usage, okay? All right. This is really where Hashmaps can be like super useful. Here's a big O example, sorry. So big O for hashes are O1 by growth, right? And that's because no matter what, when we look up a key, we don't have to look through. Remember, if you remember arrays last week, we had to look at ON, where N was the length of the array, right? In this case, we don't have to do that. We already have our key, so it's a one-to-one input, and we can find that fairly quickly. So this is where a hash can be useful, right? So you can see average worst case is ON, but average case is O1, insert, lookup, and delete, right? And as this input size is growing, the cost remains the same. All right, cool deal. All right, so let's go ahead and get into some code. Oh, I made a repellent for you guys. So this is just the code we're going over tonight. I will paste it here. And you can, oh, actually, I don't know if that's where it actually exists. Let me see, hold on. So this, basically this, here, check, let me know if you guys, can you guys fork that? Let me know if you can or you can't. Here's another one. That might be my personal. This is my, okay, cool, thanks. There, that's from the main. So basically what I did is I wanted to put everything we're going over in a repellent or a REPL for you guys. So you would be able to just see what we did. And I can try to do this for the arrays. This is what I wanted to show you. So I learned this through Liz. There's another group called Girl Develop It. And I attend their classes sometimes for, I'm in an algorithms class with interviewing and algorithms going over trees. I highly suggest looking into Girl Develop It. This is the beta, it's called OpenAI that she gave to all of us. And it's amazing because what you can do is you can go, if you go to this URL, if you go to the playground, so you can click here and you put like 3 little ticks, right? You put Ruby code. It's going to grab all this code and then it will here's Python code. And I think this is Python, but if it looks like it isn't, I'm pretty sure this looks pretty good, right? So if anyone wants to take what we have tonight and translate it into another language, use this URL. And I've put this in the chat. All right, cool. All right, let's get started on the code. I was just practicing here for you guys, making sure everything looks good. All right, so let's just go through a few things. So here, this is what a dictionary, or this is what a hash looks like in Ruby, right? We have our key and it's pointing to a value. And here's a few different examples. You have an integer that's pointing to a string, right? Here you have symbols, right? Yeah, for REPL, you may have to create an account. I don't think for OpenAI you do. I think you can, I'm not sure if I have for OpenAI. Are you, Xenia, are you asking for, oh, okay. Let me see. I am logged in. Yeah, but it's free though. It's free. Okay. Yeah, but you don't need anything more than a free account. It works fine for me on a free account. All right, so cool. So here is, we have our symbols pointing to our strings, right? Yeah, for REPL, the code probably won't work because there's some issues in that code. It's not really meant to be run because I'm putting it in each, like I want to do it inside of an IRB console because I'm just I'm most comfortable with that for Green. Oh, hey Green. I just noticed that was you. Oh, you can help me. Hi, can you help me? So
Yeah,
no, I mean for the breakout rooms.
yeah, of course,
yeah.
of
All right,
course.
cool.
Yeah, for
Let's chat.
REPL, I am able to see the code. Yeah.
I'm not
But
gonna run it. Yeah.
before I even click run, like it wouldn't even show me any
I'm
code, so I had to click run, but now it shows. I don't know, yeah, maybe it's not working, but at least I have access to the code.
no,
But
I'm
with
glad you brought
different
that
link,
up.
I
Yeah, I
couldn't
didn't
get
really
any
make,
link. Yeah.
no, that's awesome. Good point. Thanks, Dream. So this isn't like a program, so it's not going to run because there's some broken, like there's a missing value. I did it earlier as well, just to test it. This isn't going to run because like this dictionary, this has missing values, so it's going to return like it broke. This is just I just wanted to give everyone access to the code. I'm going to go through IRB and go through this way because this is what I'm most comfortable with. But for everyone, if you want to follow along, this is just the Ruby code. But yeah, Green's right, that's not going to work. So good point, Green. All right, so here we have like if you put it into a console, you like what I'm doing now, which is just like so if you have like Ruby and then, you know, .rb and you go in, right? So what I did for Ruby and my, I'm not sure what I would need to do for JavaScript, but for Rails or to get into a Ruby console, I just type in IRB. All right, so, okay, awesome. Thanks, Stephanie. It's just going to print out a bunch of stuff though. It's not really like a program. So, but yeah, okay, great. If you, thanks for letting me know, Stephanie, for showing us that. All right, so here, just because I feel like we're getting short on time, here's an example of a string pointing to an array. So we have weights and we have pound and kilogram, we have lengths, meter and mile, right? And this here, actually, I think this is how I read somewhere, a lot of programs actually store, like dictionaries this way or translations this way. So like here it's German and 1 is eins and 2 is way, and I can't speak German. So yeah, sorry for my mispronunciation, but all right, so let's go ahead and get in. Let's go through general, a few general things, okay? So here I have dictionary 1. This is my second dictionary. All right. Here's a fun little thing. If you want to do dictionary 1 equal dictionary 2, it's just going to return a Boolean true false, right? Right. This, if we do dictionary 1 dot flatten, what do you think? An array. All right. It gives us an array of the keys and the values. All right. So 1 eins, 2 zwei, 3 nil. I put 3 nil in there to show you guys compact. I don't know if you remember compact from last week, but compact will take away any nil values. So after I've run compact, I get 2 keys. I have 1 and I have 2, but 3 is not there because 3 was pointing to a nil value. Okay. Here is invert. So dictionary 2, if we do dictionary 2 dot invert, we switch our keys and we switch our values, right? These are just like a small things that are maybe helpful if you're using a hash. Here is another one that you may see often where you have 1 hash, you have a second, and we're going to merge these 2. Now, something interesting if they're the same, or if there was something earlier that I was playing around with, but it'll only if they're different, right? It'll only merge if they're different, which makes sense. You can also get the size by doing dictionary.size. Just gonna there we go. So dictionary 1.size is 3. We have 3 keys. We have 3 key value pairs. And then I actually wasn't including sort because I guess I don't really sort a dictionary that often, or a hash, but you can sort by key value, or keys. But in this case, we have 2, 4, 6, and 5. And this is sorting and puts them in this sorts it by an array, right? You see that this doesn't return a hash. This actually returns hash arrays within an array, and they're sorted, right? All right, cool. Now the more I guess the more important stuff, okay? If we want to set a value in a dictionary, in this case, we have dictionary. No, we don't have a dictionary. we could just do dictionary equals, right? I'm just going to do its own, a new dictionary. If we do dictionary 1 equals uno, we're going to set uno 1. The key is 1. So the key goes in a bracket for Ruby. I'm not sure how it is. Yeah, thanks, Del. I appreciate that. Yeah, I was looking at that earlier and I was kind of surprised by that as well. So dictionary, if you put in brackets, you put the key, which in this case, we're going to use 1, is equal to uno. And then we return dictionary, we should have a key. So we have 1 is uno. So it's pretty simple in Ruby. You just have a bracket, you have the key, the name, whatever you want that key to be, the name of the key or the value of the key equals uno, and it's going to set a key value pair. All right. So we've set the value. Why don't we get this value? If we want to get the value, we just ask, hey, dictionary, bracket, string 1, what is that value at 1? And we get uno, right? All right. Now, we're going to go over finding, accessing a key. So in this dictionary, we have 1, 2, 3, and we have the values of 1, 2, 3, and the translation into German. So if we want to access, we know how to access, right? So this is going to return our key, our value at 1. Now, what do you think is going to happen if we try to access a key that doesn't exist? Any thoughts?
Does it come up undefined?
It may come up undefined for JavaScript. Yeah, good call. It's nil for Ruby. Yeah, good job, guys. All right. So here are a few fun ways to access. I also wanted to put in the comments, like what we're passing in. So if you want to do dictionary.key, if you pass in a value. So basically you're saying, hey, dictionary.key at this value, right? And this is going to return the key where this value exists. All right. This is a bit different because this is a Boolean. So this is asking, hey, does this key exist? So in this one, we're going to pass in the key. This is very similar, and also member as well as the key question mark is the same as include in Ruby. I think include JavaScript might have an include method as well, but I'm not sure. All right. Okay. Good call. Xenia, thank you. Includes, great. Thanks, Stephanie. So it's just include question mark in Ruby. All right, so let's see. Another really nifty thing is if, like, let's say we have our dictionary, right? And I just want to get the keys of the dictionary. What do you think, you guys, what do you think this is going to, what do you guys think this is going to return? Any thoughts? Like, what type of object? Dictionary.keys. We know it's probably going to give us the keys, right? So dictionary.keys, but it's going to give us an array. It's a list of keys and it's array. Great. Thank you, Green. Yes, Dell. Oh, awesome. Sorry, I didn't see everyone. All right, cool. You got it. So this can be nifty. Like if you're like working on a problem and you're storing everything in your leak code problem and you're putting everything in your keys and then you want to do something with those keys or values because there's the same in values. So we kind of went over keys. Now let's go over values. So dictionary.fetch 1 is going to give us, where we say fetch the symbol 1 is going to give us the key, the value at that symbol. This is the opposite where we're saying, hey, I want to get the values at the keys, right? Oh, no, it's not the opposite. I'm sorry. It's the same because it still gives us the key value. I'm pretty sure you have to, I don't think fetch works with a symbol. I mean, a value. I don't think it does. But I'd have to look up. And there isn't a fetch keys I was looking up earlier. So here's another, and I want to try to hurry through this so we have enough time to do practice. So dictionary.value, in this case, we're passing in the value to see if it exists. Yes, it does. True. So when it has a question mark, it's sometimes mostly the question mark is usually like a Boolean is returned. All right, so dictionaries values at. So in this case, we're going to get the values at these two keys, and we get the two keys. So it's very similar to fetch values. And this is the same as keys that we did earlier, except it's values, right? So this could be useful if you're wanting to return an array of something like an elite code problem. All right, so we went over this, but just to go over it again, if you have a dictionary and the key doesn't exist, it's going to return. Oh, in this case, it didn't return nil, it just returned an error. So yeah, that errored out. But I think this will return nil. But let me double check. Might be wrong. So these, I guess, won't. Oh yeah, okay, good. So this one gave a nil. But yeah, thank you guys for helping out with different languages. So fetch didn't want to work at all. So I'm going to take that off and I can update the REPL. But key, if you want to do key 0, it's just going to return nil. All right, so deleting. Here's our dictionary. And if you want to delete a key value pair, we can pass in the key. Right? Now, if we look up dictionary, oh, it doesn't, sorry. Let me do dictionary delete 1. All right, and yeah, now it's gone, right? And dictionary.shift will delete, I think the last, or the first, sorry. We went over this last week. Shift and unshift. Shift is the shorter one. Someone taught me this last week, like shift is the shorter one. So it's the first one to come out, that pops out the first. All right, so enumerables, okay? Here's our iteration. These are actually really fun. I was enjoying writing these out because they were kind of fun to play with. Yeah, these are helpful. Remember, anything with each is always going to return the original array, but in this case, we're going to delete if where the key equals 1, and it returns. In this case, it's kind of nice because it returns our new array, right? Here we can go through just like any iteration, key value, and here you can see 2 equals the key, way equals the value. I'm butchering German. I knew that was a bad idea, but so sorry for any German speakers who are.
It's zwei.
It's
It's
zwei.
okay. Zwei.
Super off.
I'll fade to back now.
Sorry, Heidi. Sorry for anyone. I apologize. Okay, this is the same for each key. Thank you, though. So each key. So in this case, I'm just saying k equals key. So each key, and you can also do the same with each value. And yeah, I have a few others here. I'll just quickly go through them because then I want to put you in breakout rooms to go over. If you guys and this is reject. So I'm kind of jumping all over the place because I'm getting anxious that we're running out of time, but reject basically is the same as delete if, where we're going to reject the key that equals 1 and return the hash without that key. Okay. Here is another, which is select. Select's pretty great one. I feel like I use this often, and we're just going to grab that one key value, right? That equals. So where k equals in key, in this case, I'm kind of going through this really fast, but k in this case is key and b is value, right? And finally, we'll do keep if. So in this case, if the key is 1, we're going to keep it. Okay. Awesome. All right. So that's there for you. These are just a few like handy methods, especially like for the getting and accessing and finding a key. Those are really helpful. But yeah, going through each value, each key, each pair really helps. So in this case, I feel like I really went a bit fast over this, but if we want to go through each pair, you can see it actually returns an array. And well, I put it out. It doesn't return, it returns the original hash like in each does in Ruby, but you can put out it puts out an array of the pair, which is the key and the value. Okay. So sorry I went through that kind of quickly. I don't know if we have enough time in this class. So we're going to see how this works. But what we're going to do now is I'm going to try to break you guys up into groups. And I'm going to give you this link. It's an easy problem. And what I would suggest is please try to, write it out and think of how you could use a hash in this case to get the majority element. Try to do it without, looking at the answer, because you're going to learn more if you try to talk it out amongst yourself. Yeah, I am. I'm just trying to like preface this with here's the link. All right, that's the link. I'm going to go ahead and set you guys up into breakout rooms. All right. Let's see. I'll stop sharing. All right, let's see how this works. So, all right, so cool. All right, so yeah, go to breakout rooms and we'll come back probably in about like 10 minutes till. All right, see you guys in a bit. Hey, you guys. I need to work on breakout rooms. Sorry, that was a little messy, but it seemed like you guys were working. I saw Heidi's little like volume bar moving. I can see. So I was like, okay, hopefully it's kind of okay. I know it's hard because everyone has different languages, but
Well, the interesting thing was that because Jackie and Xenia and Patricia and I've got the Python, but we had to kind of commonly go to like what was the quorum. And
okay.
so it was mostly JavaScript with Java. So JavaScript kind of was like meet in the middle.
Okay.
But the thing was that, and I didn't want to take too much time, but I should have unpacked like with umpire, because I just jumped into like the JavaScript section and I said, I'd be willing to be your typist, but I didn't,
Great.
I don't know JavaScript from the hole in the
Yeah,
wall.
that's all
So
right.
then it was that Xenia had pointed out that in the two examples,
Mhm.
what were they really trying to go for?
Mm,
So I think, that was the thing that I had just read the first two paragraphs
all
and
right,
then
so
was
let's go
trying
over
to
it.
think
Let's go over
about
it
that.
really quickly because everyone's back,
Yeah.
Heidi. So welcome back, everyone. We were just discussing really quickly, like, sorry, I threw you guys into breakout rooms. Greem, I don't know if you heard, basically here we don't have time to kind of go by like language. So I know you guys were kind of all thrown in, but hopefully you could have pseudocoded it out if you didn't get to write it out all the way. But yeah, here is an example of, I'll share my screen of how I did it and what worked best for me. And I can walk you guys through like each line of code and why this worked. And I'm going to try to do this really quickly so I don't, so we can like discuss what you guys and your solutions were. So what the easiest way to do in this case was to set a hash or the dictionary to a new hash. We're going to iterate over the numbers that we receive, which is in our array. And in this case, I'm just showing you like, here's putting the number. This isn't actually part of the, problem. I just wanted to show you guys what's happening. So in my standout here, if you see below, each time it iterates, we go over a 3, and we're going to say hash num, make this a key, plus equal 1, and an operator in Ruby plus equals means plus and assign 1. Okay, so in this case, I'm saying like we went over before, hash, we're going to make this key the number. So we're going to set this key to 3, and we see the occurrence is 1 here. The next time we iterate, so here, let me do this so you guys can see a bit better. Or maybe I should just put an end here so it's a little easier to read. But in this case, right, this can be comment. Oh no. Oh, sorry. I went to my next tab. This can be commented out, but I'm just using it for my standout. Okay. So here the first number is 3. The first occurrence we have is 1. The next number is 2. And the occurrence that we have when 2 is set to the key is 1, right? So you can see a pattern, like if we had 4, the occurrence would be set to 1, right? That's the value. And in this case, the last one is 3 plus equals is going to be 2, because 3 is our symbol. We already have our key, and it's going to, we are going to have the value of 2 at this case, because we're going to this key. 3 is our key, and at that point we're plus 1, so our 1 becomes a 2. This is what we kind of discussed earlier before. I'm going to grab the values of this hash, what we've created in this iteration, and I'm going to get the max values, and then I'm going to return that key. And that's our answer, 3. All right, what do you guys, any thoughts? We only have like 5 minutes, but if anyone else wants to go over or discuss and like talk about the problem, I can also post this in I can post this Ruby. Let me take this out. I can post this in the thread as well. Are there any questions? There you go. But that's for
what's the 01 space one?
so, well, this is in this case. Oh, this should be 01 because we're setting it at the key value. So it should be 01 in this case as well. You mean, could you follow up in linear time? Is that what you mean?
Yeah, I wasn't, Anna. Okay, go ahead, Anna.
Oh, no, sorry, what were you saying?
Awesome.
Yeah, I was just saying that I was in Anna's breakout room and we were talking about the follow-up
Mhm.
and how if you can do it in ON time complexity and O1 space complexity. So the algorithm is ON time complexity,
Mhm.
but in terms of space complexity, I wasn't sure if it was O1 space complexity or ON space complexity.
Because I thought there could be like a maximum of n/2 different elements.
Yeah. So see what Dell wrote and kind of like what we discussed before. When we use a map, and let's just do this. every time we're going through and even like through, well, here it says space is ON, so I don't know if that's actually accurate. But in this case, we're just storing this, we're not storing it through, yeah. Actually, that's a good question. I don't know. I'd have to look at that follow-up for sure. O1 space. Yeah, I mean, the thing is, like,
I feel like for this question, we are using O of n space. I was assuming that our numbers are gonna just be 1 through 9, but it tells you your constraint, your n is up to like 5 times 10 to the 4. So you could have that much space taken up if you're keeping counters.
but
But it also says that half the array is full of your duplicate elements, right? So space-wise in that dictionary, you would only have n
exactly,
over 2 number of
right.
yeah.
Yeah, because at this point, we're storing, like, so for example, when we have 3, this duplicate is going to 1 key. Like you said, Larry. So it's half, yeah.
I think it will be O of n, where n is the number of unique elements in the array.
But I guess that'll still be n because it'll depend on n.
Let's say unique elements are n over 2. That gives us a number n over 2 max. It's never gonna go higher than that.
Honestly, I haven't looked at that, so I really am not able to give you an exact answer for the follow-up. In this case, I was really just trying to show you guys how to use a hash and how we're storing this. In an interview, I mean, it's great if you can do a follow-up question because they will ask you. If you get it very quickly, they could potentially say, well, can you solve it in this case? For this like event, I honestly did not go into the follow-up. I wasn't even sure we were going to have enough time to even get through this. So if you want to maybe try, I don't actually know what the answer for that is, but if you want to try, if anyone wants to try and then post it in our Women Who Code community, that would be a great follow-up. All right, so we can put that in the Slack community and like maybe go over that. I can say, hey, if anyone, I can post like a comment, like if anyone figured out the problem in from our event, like, can you put it here? But okay, awesome. Thanks, Del. But yeah, sorry, I actually don't know the answer to that. But that's a good those are good questions. Does anyone have any questions besides like time complexity or like space? Does anyone have any questions on like how we used our dictionary and like any questions on hashes in general?
Yeah, I have a question. So I use JavaScript, and when I
Yeah.
use JavaScript, I would like if I would iterate the array first, and then I would see if that element as a key in the hash exists or not. Like if it doesn't exist, then create that key value pair. And if it exists already, then add 1. And it seems like in Ruby, you don't have to do that, or I'm not really sure how the hash look like. Would it be okay if you print the hash? Like, do a hash look like the hash that you showed us earlier, the dictionary, that key value pair you showed us earlier?
In which case, when you're at like at the end when you're returning it, is that what you're asking?
Like right before, isn't like from line 6 to 8, you're building that hash, right?
Exactly.
So
We're
what
yes.
what's like what does hash look like now when everything gets built?
Yeah, let's look at it. That's a good question. So if we run through this and we want to check what the hash is, here, this is what it looks like, right? Because each time when we store our number as the key, which would be 3 or 2, whichever number we're going through over the array, we're adding whenever we see that number, right? Because remember, keys can have to be unique, right? So keys are unique. So each time we see that, we're going to add 1. It's plus equals to 1. So this is what the hash looks like. But then we're going to, in this case, like if we wanted to do this, right? Let's just do this and see. And this is actually kind of nifty for other, like if you want to keep track of other problems on LeetCode. Because I used this solution for another problem I was trying to find, right? So in this case, when I do puts hash values max, right? It's 2. And so when I get this, the value of the hash values max, so it's going to give me the maximum value. I add it and I pass it in as an argument to hash.key, which we went over earlier, and it's going to return the key. And the key is where we were storing our numbers or our unique numbers or non-unique numbers or our numbers in our array. Does that make sense, Green?
Yeah, this makes perfect sense. Thank
Right.
you.
You're welcome. Sorry, guys, I don't know the answer to the 01. If you guys do figure it out, like definitely let us know. Are there any other questions in terms for? Oh, awesome. Thank you, Heidi. Are there any other questions for, okay, wait, so Larry said this works perfectly fine for finding majority of it takes 2 traversals, which works in 01. Let's see what this one is. Okay. But the time complexity is ON.
Yeah,
You
so
think it matters?
so the name, so when you use you can either use an array or a hash map because they're numbers.
Mm-hmm.
But the general name for this algorithm is, I believe it's called Boyer dash Moore majority voting algorithm.
Awesome.
And there's a better analysis of the space complexity there, but because it's capped at n/2, it's considered constant
O1?
space, O1 space,
Got it.
I believe.
All right, so this kind of like takes the point out of my.
Yeah, it's
This is
very
definitely-
nuanced. I know it's very nuanced in why it's big O of 1, but I believe this.
Oh, you're saying it gives an example as, let me see, it explains why it's 01. Is that why you're saying using this for?
Yeah, I think it's an explanation of why it's 01, because it was up for, like, people were unsure. We were going back and forth between whether the space complexity was ON or 01, and I wasn't sure myself because it's kind of deceptive.
Yeah, honestly, like at first but when we look back at this chart, and this is like why I'm using this guy, this Robert Horvick as a reference, like I'm trying to get better at this stuff with you guys as well. And when the average is ON, even when we're using this. So I had to double check because at first I honestly thought it would have been 01, but I don't think, I'm not sure if it is.
Can you go back to that slide? So it depends on what you're referencing, like worst case.
I'm not referencing
Okay.
worst case. I'm referencing the average for the insert
Oh, I
lookup,
see.
and delete.
I see.
Yeah. Like ON is so, like, I think Anna said this before, like N is like, or if you put any type of letter there, that is however many times we have to iterate over. That's the number in the array. So like, that's why when we went over arrays last week, N was the length of the array, right? So
Yeah.
N would be however many numbers we have to search through or look through or hold, to put into a data structure. So I guess it does make sense because we do have to go over every single element and store every single element, right?
Yeah, you
And
do,
you would
but
need a counter.
yeah, but
Yeah.
there's a there's a duplicate element, right? That takes
Right,
more than half of
so
the array.
I
Yeah.
don't know if it is ON. It might be log of n, but I'm not sure.
Okay.
I wasn't
not log of
really
n.
looking at that.
Yeah.
I honestly thought it was just O1. But now after further like examination, I see that, yeah, I saw this on the side, but for some reason I was thinking when I grabbed this that this was going to be O1, but I'm not sure if it is. So we are over time, and if everyone, thank you, Graham. If anyone wants to like chat, or you want to like, yeah, you would reset the variable each time for whatever that like, so if we were doing like a number, if we were like going over this array and we have 1, 2, 3, it's the length of the array. So n is going to be the length of the array because we're going to have to go over this 3 times, right? We're going to have to check each, like before when we were looking at arrays last week, and if we want to go over an array, then we need to check each element, unless we know the index where that value is stored. But that's why hashes are great, because they're typically O1. Oh, awesome. Thank you, Heidi, for that. And this is Python tutor. Yeah, this is like a bit, okay. I'm not sure, Anna. I'm not sure, to be honest. I guess it depends on the array and what we're looking at, but you're going to have duplicate values.
Thanks. Yeah, you're right. There'll still be ON in time. It would just be O1 in space with that thing, I think.
Oh, right.
At least what I understood is it goes through each value in the array and then sees if it appears more than n over 2 times. And if it does, it just returns. So that's still.
For this algorithm, the majority voting, the Boyer-Moore?
That's what I thought.
Okay.
I'm not sure.
So thank you, Larry, for sharing that. So that would be follow-up, but did everyone understand the actual, like, just the first question? Did everyone get that? And how, for those, just how we used in a hash and how we were storing them? And are there any other questions? No? Are there any questions on anything else? I know it might have been really hard today, I felt like the breakout rooms weren't as successful. I don't know, do you guys like going over a practice question? Like, what are your thoughts? Okay, you do? Oh, Kat, what are you mentioning? Is this what Heidi was mentioning? Is this what you guys are saying, Heidi? You can speak, Heidi. Talk to us about this Python tutor thing that you're sharing with us.
Oh, it was just that it was walking through the code and just showing that at least when you made it as a class, not a hash map, that you essentially needed to know the count, which was what's the length of your array of nums. And then you walk through in a loop your array of nums. And since you need to keep track of a counter to know what you've parsed through, there's kinds of some list compression in there. And then you compare if the count is bigger than your total length of your array, and you're returning that number. So it's not exactly that it needs to put it in a map per se.
No, you don't. I just use this because I thought this was nice. A good way of showing.
Yeah. I'm just going to have to go off and noodle with it when I have a little bit more brain.
Yeah, I know. I feel I'm trying to show you guys here like what we're doing. I think just give it some time and like, yeah, come back to it. And when you walk through and you can see like how we're kind of storing this, right? Like when it's going through each number, it's checking the key. And if the key will always have 1 if it exists, right? It's always going to have one. But what we're looking for is the majority key or the majority number or element, right? And so that's why it's really nifty to use this. I think it's going to be harder for linked lists when we do that. But okay, so if you guys really want another problem next week, I might have to make this longer because I feel like we rushed through, like, I feel like we might have rushed through everything in terms of hashes. Are there any like comments on that or any thoughts? Like, are there any thoughts or comments?
I just like being here. I mean, I didn't have any expectations. The only
Oh.
thing I can think of is that, is there anything that you covered in your slides that you, or put in your slides that you didn't cover that we should be reviewing? And, you know, if there's anything that you think that we could do to prep for
Yeah.
the next one, maybe to meet your time constraint in the middle. That's the only thoughts I had.
Yeah, let me stop recording. Yeah, I think it's interesting, like a really great question. Yeah, I